Now, I know somebody's going to seize upon this and say, hey, wait a minute, but we don't see perspective with the sun traveling over the flat earth. We should see it shrink to a dot and disappear. We don't see that. Well, I was going to save this for another video, and I maybe still will, but let me introduce to you celestial perspective. It's different than regular perspective that we're used to every day. Regular perspective, we see a train on the tracks, and as it goes away from you, it gets smaller and smaller and smaller until it disappears. But the sun, on the other hand, is different because the sun, when it's quote-unquote next to you, is high overhead and has already experienced a reduction in size. Now, as it goes away from you, it follows the convergence lines down to your horizon, essentially keeping it same distance from you. So the two movements offset each other. The one, the sun moving away from you, and then the visually lowering as it follows the convergence lines down to your eye level horizon. Also, the sun is too big to shrink to a dot anyway, right? It's going to go below the observer's horizon before that happens. Now note this about the convergence lines. Notice that on this wall of lines, the higher up they get, the more steep they get. They orient themselves away from the horizontal and more to the vertical. So the train on the tracks, as that goes away from you, it's right on your eye level. It's actually on your z-axis. Here's a picture of the z-axis, x-axis, and y-axis. It's on your z-axis, so all you can see is the train get smaller and smaller and smaller. You can't see any movement laterally or vertically out of that plane. But the sun is different because the sun, even though it's cruising over the earth parallel to the ground, it's on a much higher plane. So when it's overhead, it's already had a visual reduction in size. So now when it goes away from you and it follows those convergence lines down, it'll appear to be the same size because the going away and the lowering kind of offset each other. And same as this train. If you put this train high up overhead, that will cause it to already have a visual reduction in size also. So now when it goes away from you, it too will maintain its size. Kind of like if you're flying a kite, right? And you have the kite and it's a mile overhead, well, it'll appear a certain size, right? But let's say it takes a nosedive, but the string stays taut, so it goes all the way to the ground. Now it's a mile further down the road from you, but it's still the same size visually, right? So that's kind of how this works.